Hello students. Today we're going to look at section 3.4, which is direct variation. Direct variation is a special kind of linear equation or linear function, and it has several characteristics. So we're going to look at those characteristics and see how we can figure out if it's direct variation or not. Okay. The first characteristic of direct variation is it has a constant of variation. And the constant of variation is indicated by the letter K, right? Now what you'll see as we go through is K and the constant of variation is exactly the same thing as the slope, which is exactly the same thing as the constant rate of change. But when we talk about direct variation, we talk about a constant of variation, okay? The second characteristic we know is the equation is written in the form of y equals kx. Now that looks really a whole lot like y equals mx because they're both exactly the same. K and m are exactly the same. When we talk about direct variation, we look at constant of variation. When we talk about y equals mx, we talk about slope-intercept, okay? So you just need to know that k and m are exactly the same thing. You've already learned how to find slope by using rise over run or y2 minus y1 over x2 minus x1. Same rules apply. And if it's a table, you're looking for the constant rate of change. All of those same rules apply. This is just direct variation, okay? Notice that with direct variation, y equals kx, there's nothing that comes after the x. There's no plus 7 or minus 3 or minus 5 or whatever. It's just y, k, and an x. No constant number out here, okay? So y equals kx. Constant of variation, slope, exactly the same thing. Another thing that you will notice about the direct variation is a direct variation is proportional. Meaning, if I have a table set up and I have x's and y's in that table, then each of those x's and y's are going to be proportional, okay? And because it's proportional, the graph of the line passes through the origin. So one way to identify a direct variation equation is if I look on a graph and I see that it goes through the origin 0, 0, then I know that's direct variation, okay? So those are the main characteristics that we want to look at when we talk about direct variation. You need to know them, okay? You need to be able to look at an equation and say, oh yeah, that's direct variation. You also need to look at an equation and know, oh, it's got k in it, it must be direct variation. And you need to look at a graph or a table and be able to look and see if the ordered pairs are proportional, and then I can see that it passes through the origin, and then I'll know that it is a direct variation. We're going to look at some examples of all of those in just a second. So let's say we're given some information, okay? This information says that suppose y varies directly as x. It's telling me it's direct variation. That's the way they say that. And y equals 72 when x equals 8. So I have to write a direct variation equation, okay? If I know that y equals 72 when x equals 8, I've got to figure out what k is, my constant of variation, okay, which is the same thing as slope, okay? So to find k, that equals y over x. All right, now we're probably wondering where that came from, so let me break it down just a second. We said that the direct variation equation is y equals kx. Well, if I'm trying to find k, I'm solving for k, then I've got to divide by x on both sides because I want to get k by itself. So that means that k equals y over x. So if I know a y and I know an x, then I can just plug in the y and the x to find the k. And that's what we're going to do. So if k equals y over x, then I'm going to plug in the y and the x that I have. So k equals 72 over 8, which equals 9. So I know that my constant of variation is 9, which also means that my slope is 9. So now, to write the equation, I'm just going to take this original equation of y equals kx, and I'm going to substitute the k. Okay? So the equation that I'm going to write is y equals 9x. That is the direct variation equation for this scenario. So once again, find k by doing y over x, and then once I find k, plug that back into the original formula. Notice that in my formula, in my equation, I have a y and an x. I don't change that y and x to a numerical value in the final product. I do have to change that y and x to a numerical value here to find k, but once I'm asked to write the equation, the y and the x are actually variables, not a numeric value. The next thing it might ask me is, find the value of y when x equals 12. So now I have my equation, y equals 9x, and it says find the value of y when x equals 12. So I'm just going to plug in what it tells me, y equals 9 times 12, so y equals 108. So again, typically when you're given a direct variation problem, it's going to be two parts. One is to write the equation first, then when you have the equation, then I can come up with a value for a different x. So let's look at one more example, okay? So suppose y varies directly as x, and y equals 6 when x equals 10. Write a direct variation equation. So the first thing I have to do is figure out what k is, and we know that k equals y over x. So I plug in my y and my x, and that equals 6 over 10. And I always need to put my k in simplest form. And no, I'm not changing this to a decimal. I'm leaving it as a fraction in simplest form, because k is the same thing as slope, and we need a rise over run, so we're going to keep it as a fraction. And so that is 3/5. Okay, so k equals 3/5. Now I'm not finished, I got to write my equation now. My equation is y equals 3/5 x. The second part of this is find x when y equals 18. So now I have to plug in the 18 for y. So 18 equals 3/5 x. I'm solving for x, so I have to divide both sides by 3/5 or multiply by 5/3. So I'm going to, since I have a calculator, divide by 3/5, divide by 3/5, and I know that 18 divided by 3/5 is the same thing as 18 times 5/3, and I know that's 30, so x equals 30 when y equals 18. So once I have that equation, I can find either the y or the x based on what they give me. Doesn't matter, just plug in what I know, solve for the one I don't. Well, let's say they ask us to graph a direct variation equation, y equals 1/2 x. Again, I know it's direct variation because there's no +7 or +5 or whatever. It's just a y and an x with a coefficient. That makes it direct variation. Okay? Well, I know it's direct variation, so the first thing I know is it's passing through the origin. So I know that one of my points is going to be 0, 0. So that's where I'm going to start. Okay? I'm going to start at 0, 0 because it's direct variation. And then it says y equals 1/2 x. Well, I know that k, my constant of variation, must be 1/2, which is the same as the slope. My slope must be 1/2. And so if m equals 1/2, that's the rise over the run. So I'm going to use that 1/2 to go from this point. It says I'm going to rise 1 and run 2, and they're both positive. So I'm going to go up 1 and to the right 2 to get my next point, because I'm just using my slope, which is rise over run. And if I want to put another point, then I'm going to start at this second point that I just drew, and I'm going to go up 1 and to the right 2, and that gives me another point on my line. Again, I'm just using what I know. I know that a direct variation equation passes through the origin, so I know that the 0, 0 is going to be one of my points. I can already put it. And I also know that my slope is 1 over 2, which is rise over run. So to get from one point to another, I have to rise 1 and run 2, up 1 to the right 2. So I know another point's going to be right there. And now that I have 3 points on a line, I could draw it. I should be using a ruler. I don't have one, but you will. And so I'm going to draw. I'm just going to do a dashed line so you can see. That is the graph of the equation y equals 1/2 x. So you are going to be starting to graph from an equation. I could create a table, and I could put points in a table, but I want us to now start what we did last year, which is graph just from the equation. You know a point on the line, 0, 0, And so now I know my slope is 1 over 2, rise over run. Go from here, up 1 to the right 2, from there up 1 to the right 2, and I have 3 points on the line. And here are your practice problems for this video. The first one says y varies directly as x and y equals 15 when x equals 3. So part A, write a direct variation equation. Remember, you have to find your constant of variation first. And then B says, what is the value of x if y equals 150? The second one, graph this equation, y equals negative 1/3 x. I know you don't have graph paper, but draw a simple x-coordinate and a x-axis and y-axis. Mark it off, just like I did, with little tick marks on the x-axis and the y-axis, and then graph y equals negative 1/3 x. Take a picture of your practice problems and submit it via Edmodo, and that's all. Hey folks, I'm just seeing if you watched the video to the very end, because you never know what comes at the end of a movie. End of a great video. Could be a surprise. If you see this message, write the number 4 on your practice problems, put a circle around the number 4, and you earn 4 extra tickets for watching all the way to the end of the video. Don't tell anybody about this. Don't tell anybody. But if you get it, put a 4, put a circle around it, and you'll get 4 extra tickets for watching this video.